You know how an AI can write a whole story or translate a paragraph and somehow remember what was said way back in the first sentence? Well, for a long time, that was a massive, massive challenge. Old AI models, they kind of read like a stock ticker, one word at a time, and they would often forget the beginning of a sentence by the time they got to the end. But then, one revolutionary idea changed absolutely everything. That idea is called attention, and it's the key that unlocked the entire AI revolution we're living through today. Let's break down exactly how it works. To really get why this was such a seismic shift, we first need to look at the wall that AI language models just kept smacking into. For years, even the really advanced models like recurrent neural networks, or RNNs, were just stuck on a fundamental problem with how they handled information. So, on the one hand, you had the old way. Models like RNNs, and even their smarter cousins LSTMs, were clever for their time, but they were stuck being sequential. They had to process text one word at a time, passing a tiny piece of memory forward at each step. Just imagine trying to read a huge novel by looking through a tiny keyhole, one word at a time. It's incredibly slow, and by the time you're on chapter 20, you've probably forgotten all the important details from chapter 1. This forgetting was a huge, huge problem, and that one-by-one process made training these models take forever. So, how do you smash through a wall like that? Well, the solution was actually beautiful because it mimicked something you and I do constantly without even thinking about it. It was all inspired by the way we, as humans, pay attention. Just think about it for a second. When you're reading a really dense sentence, one that's packed with different clauses and ideas, is your brain really just moving left to right, one word after another, never looking back? Almost certainly not, right? Let's take this beast of a sentence here. The book that the professor, who everyone admired, recommended was fascinating. Your brain doesn't just plod along word by word. Your mind instinctively jumps. It connects book directly to the word fascinating. All that stuff in the middle about the professor, that's just extra detail. Your attention isn't sequential, it's dynamic. It zips across the sentence to link the words that really matter to each other. So the big idea was, what if we could teach a machine to do that too? And that is precisely the concept that researchers built into a brand new kind of model. They took this idea of dynamic focus and they built an architecture around it that we now call the transformer. At the very heart of the transformer is this mechanism called self-attention, and really the name tells you everything you need to know. For every single word the model is looking at, it's allowed to look at all the other words in the sentence or even the whole paragraph at the exact same time. It then gets to decide for itself which of those other words are the most important for understanding its own meaning. It's not getting information passed down a long, fragile chain anymore. It has a direct line to everything, all at once. So how does this actually work under the hood? Well, you can think of it like a super fast database lookup. For each word, the model generates a query. It's basically asking a question: who else in this sentence is relevant to me? At the same time, every other word generates a key, which is like an advertisement saying, here's what I'm about. The model then matches the query to the most relevant keys, and once it finds a good match, that word shares its value, its actual meaning and context. By calculating an attention score between every word, the model creates a perfectly blended, customized context for every single word in the sentence. This whole idea just blew the doors off the research community when it was unveiled in a now legendary 2017 paper from Google. And the title says it all about just how radical this was. Attention is all you need. They weren't just suggesting adding attention to old models. They were saying you could throw out that entire slow sequential structure and build something way more powerful using only attention. And you know what? They were absolutely right. A transformer is basically built by stacking these processing blocks on top of each other. Inside each block, you've got multi-head self-attention. That's like having several attention mechanisms all working at once in parallel. Each one might be looking for a different kind of connection. Maybe one focuses on grammar, while another looks for who did what to whom. After that, the information goes through a standard processing layer. And maybe most importantly, there are these things called residual connections, which act like express lanes, letting the original signals skip some of the processing. This makes sure the model doesn't get confused or forget the basics as it gets deeper and deeper. Now, this wasn't just a small step forward. No way. This brand new architecture gave transformers two, superpowers, really, that let them completely take over the world of AI. The first massive advantage was speed, a lot of speed, and it's all thanks to something called parallelism. See, because the transformer doesn't need to crawl through the sentence word by word, it can look at the entire thing all at once. For modern computer chips, like the GPUs and gaming computers, which are designed to do tons of things in parallel, this was a match made in heaven. Training times didn't just get shorter, they fell off a cliff. Suddenly, you could train these models on gigantic amounts of data in a fraction of the time. And the second superpower? It completely solved that annoying memory problem we talked about. By giving every single word a direct line of sight to every other word, transformers became absolute masters at understanding long-range dependencies. The connection between a character introduced in Chapter 1 and what they do in Chapter 30, that's no longer lost. This ability to see and understand context across huge distances is what makes modern AI feel so incredibly coherent. So with these two game changers, insane speed and perfect long-term memory, the transformer didn't just become a better model. It became the blueprint. It became the fundamental building block for a whole new era of artificial intelligence. The original transformer was actually built in two halves: an encoder, which was designed to read and understand an input, like a sentence in English, and a decoder, which would then generate an output, like that same sentence in French. Perfect for translation. But then, researchers had an amazing idea. What if we just used the decoder part? A model whose only job is to predict the very next word in a sequence? Well, it turns out, that one simple task, when you scale it up with an unbelievable amount of data, is the secret sauce behind generative models like GPT that can write code, poetry, anything you ask. And the results were just immediate and explosive. That paper drops in 2017. By 2018, you already have landmark models like BERT and the very first GPT. And just a couple years later, in the 2020s, you get what can only be described as a Cambrian explosion of large language models, LLMs, all built on that exact same transformer foundation. Without this, there's no ChatGPT, no Bard, none of the incredible generative AI tools that are changing our world as we speak. So that's the whirlwind tour that brings us right up to today. And to understand what's coming next, it really helps to just lock in on that one core idea that started this whole revolution. Here's the bottom line. The transformer blew past the old speed and memory limits by swapping out that slow, one-word-at-a-time process for this idea of parallel self-attention. And that breakthrough, it didn't just make things a little better, it unlocked the ability to scale these models to a size and power that nobody had ever dreamed of, leading us directly to the incredible LLMs we have today. Okay, so now we have this incredibly powerful engine, the architecture that makes it all possible. But an engine needs fuel, right? And a driver at the wheel. In our next explainer, we're going to put all the pieces together. We'll dive into how these gigantic transformer models are trained on basically the entire internet, and most importantly, how they are then fine-tuned and aligned with human feedback to make them safe, helpful, and useful AI assistants. Thank you so much for watching. You know, Knowledge Equity Partners is a multilingual channel, and our whole goal is to share contemporary and practical knowledge on all kinds of topics that can really enhance your daily life and just make things more effective and efficient for you. If you're getting value out of this content, we'd love it if you'd subscribe to Knowledge Equity Partners. That way, you'll get notified whenever we post new stuff. And of course, don't forget to like, share, and spread this knowledge with your family, your friends, and your community. Let's work together to keep that quest for knowledge always high. Definitely be on the lookout for our next episode for more information.